Welcome to Urban Agriculture Field Experiences, Lesson 8 of the Intro to Urban Agriculture, Growing with Water, offered by the Lehigh County Conservation District with support from the National Association of Conservation Districts, the Ryder Pool Foundation, and the Harry C. Trexler Trust. The success of traditional farming methods is dependent upon many things. Some of the basics include weather, climate conditions, and availability of natural resources such as soil. Extreme weather events and adverse climate conditions experienced in the last century, like Earth's warming, floods, and drought, have all contributed to the things that reduce agricultural yield. As the agriculture community gears up to solve for a human population slated to reach 9 billion people by 2050, thinking outside the box has become a big part of the agricultural advancement and technology. The lesson begins with a focus on water because it is necessary for all types of agriculture. The management of stormwater, however, can be quite challenging in every setting, and particularly in the metropolitan areas where much of the ground has been developed and there are many paved surfaces. Students will be introduced to several stormwater best management practices, also known as BMPs, including green roofs, permeable pavers, tree trenches, and riparian buffers, all of which are useful in controlling runoff water and keeping our freshwater supplies as pollution-free as possible. During this lesson, teachers could even choose to build and decorate a BMP as they construct a rain barrel for stormwater collection and garden use. Aquaponics and hydroponics are the next area of exploration in Lesson 8. Walt Disney introduced the world to soilless growing in 1982 through the Living with the Land exhibit at Epcot. This sort of aquaponic and hydroponic technology allows us to dream of growing food and providing medicine without any faraway places, even in outer space, regardless of climate, natural resources, and without pests, pesticides, and herbicides. Aquaponics farming is a synergistic growing technique where fish and plants are grown together in the same system. This combination of fish farming and soilless plant culture is a natural, organic method of plant production that uses no herbicides, pesticides, or chemical fertilizers. The fish culture is established without the use of antibiotics, medications, or growth hormones. Hydroponics is a grow system that uses the circulation of nutrient-rich water around plant roots to grow plants. The benefits of growing with aquaponics and hydroponics make it an important part of agriculture to consider in the 21st century. Some advantages include the reduced usage of natural resources, a lengthened growing season leading to greater crop yield, the reduction of impacts on the environment, and a reduction of weather or pest-related problems. Aquaponics actually provides a well-rounded protein and plant-based diet because not only can the plants be harvested, but so can the fish. Crops that grow best in aquaponics and hydroponic systems include tomatoes, cucumbers, lettuce, peppers, microgreens, strawberries, blueberries, and basil. Now that we have some background, let's explore Lesson 8, Growing with Water. Lesson 8 PowerPoint Review, Growing with Water. A molecule of water, otherwise known as H2O, consists of 2 hydrogen atoms and 1 oxygen atom. Aside from water's liquid form, it can be found in its solid form, ice, and its gaseous state, water vapor. At room temperature, water is a liquid with no smell or taste and can dissolve and transport many substances. Scientists believe that Earth's atmosphere, which is largely comprised of water vapor in the form of clouds, was derived when gaseous stars containing water vapor collided with one another to form the Earth. Comets containing ice collided with the Earth at this time, also contributing to the origin of water on Earth. The United States Department of Agriculture reports that 80% of the United States' fresh water is used agriculturally in the irrigation of crops and the care for livestock. A rain barrel is a best management practice placed under a downspout to collect rainwater. It helps to mitigate stormwater runoff and serves as a supply of water that can be used for outdoor purposes such as gardening or washing cars. Rain barrel water should not be consumed. This best management practice directs runoff from impermeable surfaces such as a roof or a driveway to shallow depression gardens filled with plants tolerant of water that absorb, filter, and slow erosion from runoff. These gardens also provide animal habitat and pollination benefits. A smaller version of a rain garden is a downspout garden that is placed directly near a rain gutter outlet. Do you have a downspout at home or school that you could install this BMP? This best management practice involves covering a roof with plants to absorb stormwater runoff. These roofs may also provide a space for urban farming or recreation spaces for residential housing. How would you design a green roof if you lived or worked in a skyscraper? This best management practice is the vegetation found on the land next to a river, stream, or creek. It is important to keep the banks from eroding during high water events, and the root systems of the plants will filter water running off from nearby properties, protecting the stream from pollution. Riparian buffers can benefit a community in other ways as well. Can you think of a few examples? Cities often install tree trench BMPs for stormwater control and to provide extra shade and animal habitat. A tree trench involves planting a tree on top of an underground reservoir comprised of topsoil, the tree's roots, and the layers of rocks. An associated inlet for stormwater leads to these layers, which infiltrate and slow the entrance of stormwater into the storm sewer system. What tree species might be a good species for implementation of this BMP? This porous paving is a BMP that absorbs stormwater and infiltrates it directly into the ground beneath, rather than allowing it to run off. Though an excellent management practice, it does require routine vacuuming to keep the pores in the pavement surface from blocking up with debris. Aquaculture is the practice of raising aquatic animals such as crayfish, fish, frogs, snails, and freshwater shrimp for human use or consumption. Aquaponics farming is a growing technique where fish and plants are grown together in the same system without soil. This combination of fish farming and soilless plant culture is a natural, organic method of plant production that uses no herbicides, pesticides, or chemical fertilizers. The fish culture is established without the use of antibiotics, medications, or growth hormones. Symbiosis involves the interplay between two organisms, and these interactions usually lead to the reward for both organisms, otherwise known as mutualism. A well-known example is a clownfish living within a sea anemone. The sea anemone provides habitat and protection as the clownfish lures prey for the anemone. How are bees and flowers symbiotic? How is an aquaponics system symbiotic? The inputs in an aquaponics system involve fish waste, or ammonia. This ammonia is converted first to nitrites. The nitrites then must be converted to nitrates, which is a usable form of the ammonia that, when absorbed by the plants, allows for growth, or the foundation for proteins. Outputs of this process include oxygen and filtered clean water, which are both directed back to the plants. Hydroponics is a growing system that uses the circulation of artificially nutrient-rich water around plant roots to grow plants. There are several benefits of growing with nutrient water. This type of agriculture requires 90% less water and produces crops in up to half the growing time, depending on the plant. Because nutrients are already being provided, no fertilizers are needed. Growing and harvesting are not dependent on the time of year either. In fact, harvesting can take place year-round. Farming can take place in non-traditional places as well, such as repurposed factories or mills, and these environments can easily be controlled for pests or climate. Farming with hydroponic, aeroponic, and aquaponic all involve technical knowledge, and there are considerable startup costs for some systems. Also, some micronutrients needed for healthy plants are not available as grow solutions. Finally, the health of the fish will always be dependent upon the health of the water being used. In February of 2020, Forbes reported that Aquafarms Africa is successfully launching many entrepreneurial farms in Guyana. Their farmers are producing many sought-after fruits and vegetables for local stores who had previously been importing these goods. The price now goes to the local farmers who retain the profit. During the 8th week of this course, educators can use the vocabulary list and activities provided in Growing with Water to give students a basic background regarding best management practices and growing with aquaponics and hydroponics. Students can help build and decorate rain barrel systems which conserve water, reduce stormwater runoff, and is quite useful for watering plants if placed near an outdoor garden area. Students may also be fascinated to learn that there are multiple ways of growing plants without soil. They can experiment with some of these ways as they grow seeds in vermiculite gardens and transplant them into hydroponic pail gardens.
Hi, thank you so much for joining us today. My name is Jolie Shylak and the Lehigh County Conservation District, and I would like to thank you for joining us for this 8th installment of our urban agriculture curriculum. This lesson is called Growing with Water, Aquaponics and Hydroponics Technology. So let's talk a little bit today about what aquaponics actually is. Hopefully you're learning a little bit about that as you read through the lesson. But it's basically circulating water between a fish tank and grow beds. So we're using fish to supply the nutrients to the grow bed, which has the plants in it. And it's a big cyclical system that allows benefits, symbiotic benefits between plants and fish. So the fish are in a tank and they're going to the bathroom and producing nutrients. And then there's a grow bed, and the water is filtered to the grow bed, and the grow bed will actually, as the water goes through the grow bed, the seeds will grow, and the roots in the grow bed will clean the water as it enters back into the fish's ecosystem, and that maintains their ecosystem in a clean way. So those are the benefits. The fish get the clean tank, and the plants get the nutrients from the fish. That's aquaponics. Hydroponics is very similar, except there are no fish involved in it. It's just using nutrient water that is circulated throughout the roots of plants to help them grow. And this is a really efficient way to grow plants, and it's very beneficial in areas where your natural resources are limited. So today we're going to work on a simple hydroponic system, which is great to use with kids. It doesn't involve caring for any animals because the nutrients are already in the system. Right here we have a bucket of pea shoots that are growing right now. So let's go into how to do this and what we need to begin with. So you'll need a bucket. This is a 2.5 quart bucket. And you also have to have a lid. And you might be using a bucket of a different size. And if that's the case, just be sure that you have a lid that is flexible, because we're going to be cutting a hole into this lid. You'll also need a net pot, and that's the reason that we're cutting the hole in the lid. And some rock wool starters, seed starters. They're called grow plugs. If you don't have those, you can also use what I've used in this system, which are the clay pebbles for growing. You will need growing nutrient solution. Here we have 3 different types. One is for the vegetative growth, one is for the actual growth of the plant, and then the last is for the blooming stage of the plant, the floral and fruit bloom. So you can decide what sorts of nutrients you want. And then, of course, you need water and a measuring apparatus to measure into. Another thing that you'll need are a pair of scissors and a spoon for stirring and a pen. And then, of course, you'll need your seeds. And if you can start these plants by seed. We've done that very successfully, but then you can also use plants that have already been started, and you just need to have their roots rinsed really well so that it's not contaminating the system inside. Okay, so let's get started. The first thing to do is to make the hole for the net pot. And so this is the net pot. If you don't have these, you can actually make something similar to this with a yogurt container. I've seen people use little hole punchers to get to sort of give it a basket sort of weave, or you can cut into them a little bit. Some people just cut little strips all the way down. So whatever you're using, it needs to be sort of like a basket that will sit inside this lid. And you'll notice that this net pot is smaller on the bottom and larger on top. We're going to trace the net pot, and we want to make sure that we use the smaller side to trace, because of course if we use the larger sides, it's going to slip right through. So let's do that. This will require steady hands of your kids, so tell them to be really careful about this part. We're making our circle around the outside. Nice and neat. And because this lid is flexible, the cutting is a lot easier than you might imagine. You can cut this in half if you want. Fold it in half and then cut on the half to make a little hole. Okay, and you can see I'm just using a small pair of scissors, and then I'll cut around the outside here. All right, so that's going to go right on top eventually. Let's take it off for now, because the next thing that we're going to do is fill our bucket with water. And there's a little line here. We're gonna fill it up to that line, just because when we move it around, we don't want all the water sloshing out, even though the user sometimes sloshes the water out. Okay, so we've got our water in there, and then it's time to add the nutrients. Remember, in aquaponics, the fish would be adding the nutrients, but we're doing hydroponics now, so that we're going to add chemical nutrients. For this 2.5 quarts, we need a very small amount, only 3 milliliters of each type of grow solution. And you will choose the grow solution that you want to use. And just like in a chemistry class, what we're going to do is fill it up. This is a flask that is 50 milliliters, and we're going to fill it up to the third line here. And you want to look at it on the meniscus, which is the bottom part of the curve of the liquid, to see where we are. And I actually think I got it the first time, which is sort of incredible. So we'll put the first solution in. I'm not wearing goggles today, but since we are using chemicals, it would be a good idea. So with your class, if you have some safety glasses, that's a great thing to have. So our second solution. Okay, that goes in too. And then our third bit, you want to make sure that all of it's poured out. That's pretty close. All right, so this is all going in here. I'll cap these on and make sure I put the right lids on the right ones. And then we'll stir it up. A little straw. So it all kind of sunk to the bottom, so I'm stir it up now. And then it's time to do the fun part, which is put the plants in. Oh, I have a little whirlpool going in there. Okay, so we can put our top on and then prepare our plants. I'll put this here. So it's actually a good idea to use plants that have already been started, and you sort of can feed their roots down through the little holes in the. This is tricky. It would be helpful if I had a toothpick to, kind of help guide the roots down. I can use the scissors. So you want to put the roots down into the basket of the plant and pull them through, and the reason for that is then they're going to have their contact with the water. And then of course you would add your clay pebbles, just like what's in here, and that will stabilize them. But if you don't have access to the plants, and like I said, you would take the plant and wash the roots off of all the dirt, but you could also use these plugs as well. I have 3 different ones here, so that means I can start 3 different types of seeds. Place them in there, kind of in a triangular shape. And now the fun part is deciding what you're going to put in. Maybe you want to make a hydroponics garden that has basil and tomatoes, and then you could maybe harvest some wonderful vegetables somewhere down the line for a caprese salad. Maybe you want to make a salad garden where you use kale and lettuce, and maybe a third could be herbs. Or maybe you like flowers and you want to start a pollinator hydroponics garden. We actually keep larger hydroponics gardens like this outside in our urban ag classroom, and we grow flowers in them, and they serve as sort of like our pollination station. But today let's do some basil, and all you really need to do is put about 3 or 4 seeds in each one of the cells. I think I'm going to do 2 basil plants and 1 tomato just because of the way that they grow. So I'm going to add 3 or 4 seeds. People always think, oh, you got to put a lot in there. You don't need to put a lot in there. 3 or 4 seeds is plenty. Something should germinate from that bunch as long as your seeds are, the packet says that you're using seeds that are viable right now. Mine says you can use them till 2020. That's good. December of 2020. So do my tomatoes in the third one. Ooh, there are not very many seeds in that tomato package. There we go. Okay. So put about 3 or 4 in there. And then I think a good thing to do before we insert the plug is to just get them wet to begin with. They're going to stand in there a little nicely. If I just push them right in, they're going to probably tip over a bit. So I'm going to insert them into the water just to give them a little weight. The plugs are a lot like a sponge. Okay, put this back on. Tightly. And then we're going to push this in. And I can see that the water is hitting the bottom of the plugs, which means it's going to continue to absorb. And then it's just time to put it in light. If it's during, closer to after your last frost, you can have these go outside. If you have some grow lights inside or a windowsill, you can put them there and just wait for them to germinate. And it's a pretty efficient process because the nutrient water doesn't have to travel through soil to get to the roots of the plant. It's already soaking in it. So it's a very fast way to grow plants. And as I was saying earlier, it's really a great method of growing when natural resources are limited. If you can, get a hold of the nutrient solution that you need, it's a wonderful, fast way of growing plants. It doubles the time at least of a plant being able to grow. And this is being used today to solve real-world problems like hunger in regions where food is scarce or where the climate is just too difficult to grow plants in. So I hope you've learned a little bit from this lesson, and I thank you for joining me. Have a good rest of your day.
If a teacher and/or students are willing to take on the responsibility of one or several class pets, students may extend their learning by creating a personal aquaponics grow system that incorporates a betta fish. This unit provides excellent opportunities for field trips as well. Some options include visiting college aquaponics and hydroponics labs, catering or restaurant operations, or markets that sell aqua or hydroponically grown food. To teach about stormwater management in your location, arrange to take students on a walking tour of your town to find green roofs, vertical green walls, tree trenches, or other pest management practices. And finally, researching how aquaponics could be used to benefit your community or community where traditional farming methods are not possible can lead to some great business ideas. We hope you enjoyed our quick lesson on the Intro to Urban Agriculture, Growing with Water. For more information on the Urban Agriculture Field Experiences lesson plan, please visit www.lehighconservation.org or follow us on our Facebook, Instagram, or YouTube pages. Thanks for watching, and be sure to check out the rest of the videos in the Urban Agriculture Lesson Plan series.